Yes, class. So in the last class, we had started with terminal velocity. So on the basis of that, only this question was there. Let me discuss it. So by now you must have written the question and have tried it once yourself. This says that with what terminal velocity will an air bubble of density 1 kg per meter cube, and see, density is given as 1 kg per meter cube and the diameter is given as 0.8 mm in diameter. This rises in a liquid of viscosity 0.15 Newton seconds per meter square. All right. Specific gravity, this I have told you that this is the relative density, specific gravity. What is the terminal velocity? This has to be calculated. Terminal velocity of the bubble, coefficient of viscosity is given. This is the density given. This is the radius which is given to you. And this is the coefficient of viscosity given. This is the coefficient of viscosity of the water. This is the coefficient viscosity of liquid. See, this is eta L, coefficient of viscosity for that. This is just eta. That is, this is for water. That's the difference between these two. Now, how will you calculate these? See, I have always told you, whenever you have questions from any of the lessons of physics, what you have to do, first you have to write the data that is given. Then only you will be able to figure it out, what all things are mentioned, what all not. So radius, this is 0.8 by 2, which is equal to 0.4 millimeters. This is equal to 0.4 into 10 to the power minus 3 meters. Fine. Coefficient of viscosity, this is 0.15 Newton seconds per meter square for the liquid. Acceleration due to gravity, you will take it as 9.8 meter per second square. Correct? When it is specific gravity, when we are talking about specific gravity, this is 0.9. What is the density of the liquid air bubble that is given to you? How will you how will you know what is the density? See, you know the relative density. The problem with us is that we do not know what's the density of the liquid because it's not given. Only the density of water has been mentioned. Now, how will you calculate? Right, that is the problem. So how, in such questions, how will you begin in your exam? Whichever something extra is given to you, pay attention on that. Like specific gravity. There wasn't any use of specific gravity in the terminal velocities formula, but this is something extra that is given. Whenever in your exam, whenever you'll be having a physics exam, just pay attention to this. Why is specific gravity mentioned? If you're not able to relate, then write down the formula. Specific, all these things we have though discussed in the regular classes. Now, this which I'm telling you, these tricks, this is not just for class 11th exams. Soon after 2 to 3 months, you'll be coming in class 12, then you have to study everything and then you have to solve numericals, you have competitive exams, so that you have to remember. So specific gravity, you know the formula, it's the density of the body by the density of water. Density of water we know, specific gravity we know. Can't we calculate the density of the body? This is how you have to calculate it. So if something extra is given in your exam, no, just understand something is fishy. Why is it mentioned? Now, density of the liquid that wasn't given will be 0.9 into 10 to the power 3. This is the density of water. This is 0.9. One thing, class, I'm telling you, especially, I remember Amna is going to have her exam soon. So whenever you are having your exam, please remember this, because throughout your entire physics, not just in your class 11, but especially in your class 11, density of water is extremely important. You should remember it by yourself. It won't be mentioned in the question every time. There are chances that the mention of the density's value is given, but it's not necessarily needed. So what is the density of water? When we are talking about the density of water in SI unit, we have In SI unit, we have 1000 kg per meter cube. You have to remember this. And what is the CGS unit? This is 1 gram per centimeter cube. All right. This you have to remember. Some things are there, no, which we always remember. This I have told in my classes also. Amna, you weren't there, so specifically I'm telling it for you again. Some things are there which you have to remember at the end, that are given or not. Like in your class 12th, when you'll be coming in class 12th, you will see one electron volt value is mentioned. So in this, you have to remember the electronic charge. Right now, I'm not telling you, I'm just giving you an example. No matter whether it's given or not. Like this universal gas constant, this value you have to remember, whether it's mentioned or not. Planck's constant, some constants are there whose value you have to remember. But amongst these values, the data part, at least the density of water you have to remember, because that is helpful in your thermal physics and your fluid, especially fluid, everything, anywhere it's needed. The density of the liquid, that is 0.9. Just wait. Density of the liquid is 0.9 into 10 to the power 3. That makes it 900 kg per meter cube. And what is the density of air bubble which is mentioned? That is already given in the question as 1 kg per meter cube. Now coming to the formula of terminal velocity. Now you see every data is present. What is the formula of terminal velocity? 2 by 9 r square into g rho minus sigma by eta, coefficient of viscosity, right? So this is 2, radius is 0.4 into 10 to the power minus 3 whole square. G is 9.8. One more thing regarding acceleration due to gravity. If it is mentioned to take G as 10 meter per second square, then only take if it is mentioned. If nothing is given, just take it exactly as 9.8 meter per second square. Exact value if nothing is mentioned. Nothing is mentioned, then you have to write it. Then 1 minus 900 divided by 9 into coefficient of viscosity was. This you can solve, whatever will be the answer, that will be the. One more thing. In this question, when you will be solving, in your exam, if you notice, terminal velocity is coming negative. I think the answer to this is 0.0021 meter per second square. Examiner, what all modifications can be done in this question? Examiner can further ask you why there is a negative sign in your velocity, right? Because we have written 1 minus 900. Density of the body, density of the liquid. This is lesser. So it means if the density of the liquid is more and something is very lighter. Have you seen water and air bubble case? Let me explain this. See, suppose you have a container. In this container, you have filled it with water. Fine, you have filled it completely with water. You have two things. One is air, one is water. Density of the liquid is more than density of air. Like in this question, 1 minus 900. 900 is so huge in front of this one. So the lighter object floats. Air bubble, that is air bubble. You must have encountered this also. Air bubble slowly goes up. We see air bubbles coming up. So in the exam, you have to mention this fact that this negative sign, it tells you that air bubble will rise up. Air bubble will rise up. Then further, you can calculate the terminal velocity of the air bubble separately. Write down this. See, this says that an iron ball of radius 0.3 centimeters falls through a column of oil density 0.9 gram per centimeter cube. It is found to attain terminal velocity of 0.5 centimeters per second. See, this is given in the CGS unit centimeter. Here you have centimeter, here you have centimeter. So no need to convert it. And density of the iron is also given in centimeters. What do we have to calculate? We have to determine the viscosity. We have to determine the viscosity of the oil. That is, what is eta? This we have to calculate. What all things are given? Radius, this is 0.3 centimeters. And terminal velocity is 0.5 centimeter per second. Density is 7.8 gram per centimeter cube. And the density of this iron ball, density of oil, this is 0.94 gram per centimeter cube. This is for iron. This is for oil. Now, when we write down the formula, terminal velocity, this is 2 by 9 r square g rho minus sigma by eta. 2 by 9 into 0.3 whole square into 980 multiplied to 7.8, sorry. 7.8 minus 0.94 divided by 0.5. So this will be 2 into 0.3 into 0.3 will become 0.09. This becomes 6.86. This is 980 divided by 9 into 0.5. This becomes 4, 9. This becomes 0.01. So this will be 268.9 poise because this is the CGS unit. Note it down. Okay, now see, about the laminar flow and the streamline flow. One question that often comes in your exam is to write the properties of the streamline flow. So some properties, just have a look at the properties that are given. So these probably, let me just show you first. These are the properties that are mentioned. Hmm. So the flow is called turbulent flow. This is the definition of turbulent flow. It is accompanied by random, irregular local currents called vortices. This is about the turbulent flow. What you have to pay attention on is the streamline flow. What are the properties of the streamline flow? In a steady flow, no two streamlines can cross each other. If they do so, the fluid particle at the point of intersection will have two different directions of flow. This will destroy the steady nature of the fluid flow. So it means two streamlines cannot cross. And this point is very important because you have separate questions from this point. Why two streamlines cannot intersect with each other? Why two streamlines cannot intersect with each other? So answer to that question is this. Tangent at any point on the streamline gives the direction of velocity of the particle at that point. Greater the number of streamlines passing normally through the section of the fluid, larger is the fluid velocity at that section. Fluid velocity remains constant at any point of the streamline, but it may be different at different points of the streamline. All right. Now, apart from this, you have to formula to find out whether it's streamline. So the Reynolds formula, you have Reynolds number. This is rho Vd by eta. We have seen this, and one was critical velocity, that was 2000 into coefficient of viscosity, that is eta, into rho by d. D is not the density here, D is the diameter. D here is the diameter. This is density. This is coefficient of viscosity. So between 0 and 2000, this is the flow is known as laminar flow. Above 2000 or 2000 and between 2000 and 3000, the flow is unstable. Any values can be obtained. Then you have, lastly, you have Bernoulli's theorem. Under Bernoulli's theorem, you have the formula of equation of continuity first. Equation of continuity is also used a lot. A1 V1 is equal to A2 into V2. So first form of Bernoulli, that is the pressure constant by density plus GH plus half V square. You start with this equation and then the rest of the Bernoulli's equations come. This is half V square. This is constant. But what is the second form of Bernoulli? That is also used in the numericals. Second form of Bernoulli is that P by rho g plus H plus V square by 2g. This is equal to constant. What is the volume of the fluid flowing? This is A1 into A2 under root 2gh by A1 square minus A2 whole square. And one more thing that comes, that is this is also very important for, from fluids, the Torricelli's theorem. Torricelli's theorem, where the velocity of efflux is asked, and that is related to, and it gets related to your motion in a plane lesson. So velocity of efflux is under root 2gh. This is very important. Note down these things, these points, and we'll see one question from Bernoulli's theorem. Especially write down this. This is very important. Yes, see. So in this question, a fully loaded. Yes, so this says a fully loaded Boeing aircraft 747 has a mass of 3.3 into 10 to the power 5 kg. Total wing area is 500 meters square. It is in level flight with a speed of 960 kilometer per hour. You have to estimate the pressure difference between the lower and upper surfaces of the wings. Then estimate the fractional increase in the speed of the air on the upper surface of the wing relative to the lower surface. The density of air is 1.2 kg per meter cube. Acceleration due to gravity is 9.8 meter per second. So see, change in the pressure will be change in pressure and area multiplied. That will give you the force. Pressure multiplied to this area gives the pressure into area gives the force, which is equal to mass into acceleration due to gravity. So the change in pressure will be mg divided by a. What is the mass? Mass is 3.3 into 10 to the power 5. Acceleration due to gravity is 9.8. Wing area is 500 meters square. So this is equal to 6.47 into 10 to the power 3, which is equal to approximately 6.5 into 10 to the power 3 Newton per meter square. Then in the second part, it is saying velocity V1 and V2, this is given to you. So P1 plus half rho V1 square, or directly let's write down the formula of the pressure change. So pressure change will be rho V2 plus V1 divided by 2 into V2 minus V1. This is equal to rho V average V2 minus V1. So V average will be V2 plus V1 by 2, which is equal to 960 kilometer per hour, equal to 267 meter per second. So when we are calculating the percentage change, therefore this V2 minus V1 by V average. This is equal to change in pressure by density into V average whole square. This is equal to 6.5 into 10 to the power 3. Density is 1.2. V average is 267 whole square. Answer will be 0.08, which you can write as 8%. So 8% will be the final answer. Note down the solution. Yes, Siddhika, you can leave. That completes with the revision of fluids. Tomorrow we'll continue with something else. Thank you.